All right, welcome to part 3 of this 3-part lecture. So, I think the first thing I want to do is let's start with doing something that we really did in part 2, but it's worth repeating. So let's do completing the square again on another example. If you want to skip this, then please feel free to skip ahead in the video a little bit. Let's apply completing the square to another polynomial. I'm going to change the example to one that's not literally the one that you just did. Gosh, how about 3x squared plus 4x plus 5? Let's try to think about that quadratic function. So let's apply completing the square. So 3x squared plus 4x plus 5. Right, there were these two different philosophies where you could like match up some symbols, or the one where you say, well, let's set that equal to y. Sorry, I should give a little bit more space above. Complete the square. Let's apply completing the square to figure out what that. Let's complete the square on that. So what do? Step 1 was get the constant term over to the other side. So 3x squared plus 4x equals y minus 5. The next thing to think about is, well, this like x plus b squared had a 1 in front of the x when you FOIL it out. So let's move that to let's divide everything in sight by 3. So divide everything in sight by 3. Divide all of that by 3. Divide all of this by 3, because the only way you preserve equality is if you divide absolutely everything by that number. And what do you wind up with? You wind up with x squared plus 4 over 3x equals y over 3 minus 5 over 3. So when you see addition or subtraction in the numerator of a fraction, you can distribute division over addition and subtraction. All right, cool. So this is the thing that is supposed to have the role of 2 times b. So let's write that out. That's x squared plus 2 times, well, 4 times 2 is 2, so that's 2 over 3 x. I'm going to give myself some space right here, equals y over 3 minus 5 over 3. And the whole point, oops, I need more space than that. Why did I give myself this space right here? Because right here is where I now want to put b squared. There's b. B is 2 over 3. So b squared, that's plus 2 over 3 squared. You also need to add that to the other side. So that's 4 over 9. All right, so where does that put us? Where does that put us? So this, no, I don't need a long term. This part is a perfect square. It's something that looks like x squared plus 2bx plus b squared. So I can rewrite that side as x plus b squared equals the right-hand side. Y over 3 minus, and you know what? Between these two, let's get a common denominator so we can add them in a second. Minus 15 over 9 plus 4 over 9. So that's y over 3. Negative 15 plus 4 is negative 11, minus 11 over 9. Add 11 over 9 to the other side. X minus 2 over 3 squared plus 11 over 9 equals y over 3. Multiply both sides by 3. 3 times x minus 2 over 3 squared plus 11. Let's see, multiply the 3 over to the other side, so it'll be like times 3. One of those 3's will cancel with the 3 inside of the 9. Plus 11 over 3 equals y. So instead of thinking about this quantity, it is now exactly equal to this quantity. So if you want to solve this equation, instead you can think about solving 3 times x minus 2 over 3 squared plus 11 over 3 equals 0. And here's the point of why that's useful. You can now solve this without appealing to this quadratic formula, which is like kind of a magic formula. Now, you don't know where it's true. That's why I call it magic. So let's see what you would do to solve this. I guess you would start by subtracting this to the other side. Right, so backing up further. There's only one x in this formula. Whenever you see a situation where there's only one x in a formula and it's set equal to 0, you can just try to get everything other than the x to the other side, one move at a time. Eventually, you'll have x on its own. So start by getting the 11 over 3 to the other side. 3 times x minus 2 over 3 squared equals negative 11 over 3. And maybe you already see a problem. If you don't, then we'll just keep on going. Let's divide this 3 to the other side. X minus 2 over 3 squared equals negative 11 over 9. So right, what do you get when you divide by 3 and then divide by 3 again? You divide by 9. You need to take a square root of both sides. Let's get rid of this 2. X minus 2 over 3 equals, well, there's a plus or minus. Whenever you get rid of a square with the square root, you lose plus or minus information. Square root of negative 11 over 9. And there's a problem here, isn't there? You see a negative in square root. Which, as we've seen before, that just means there are no solutions to this equation. Or maybe we didn't. The whole like versions issue on how this lecture has been recorded is getting me confused. So completing the square can let you solve quadratic equations. And it might seem like that's a step backwards from just knowing the quadratic formula. But think of it this way, completing the square is a technique. It's a technique that if you just keep following it, each step is elementary algebra, ends up with you having the form of completing the square. Once you have it in the form of completing the square, you can solve that equation without the quadratic formula, without knowing that magic formula. And that's an ad for the extra credit for today. So there's one last comment I want to make as far as completing the square. There's a formula that does it for you. Any degree 2 polynomial, ax squared plus bx plus c, can be rewritten in the form that you get out of completing the square as follows. A x plus b over 2a squared plus c minus b squared over 4a. And this might look like just another magic formula that you'd have to remember, but it's not magic because we can check it fairly easily. Sorry, there are dogs barking upstairs. It's probably someone walking across the street. I don't know if you can hear it over the Zoom. So let's check this by foiling, and there's plenty of space right here. Check by foiling. So let's take this quantity and see what happens when we just expand it. It almost worked perfectly. Let's see what this becomes. So the a will leave that alone. This bit, you know what? That looks like a square. Let's FOIL it out. A times x squared plus 2xb over 2a. All right, this 2, because when you FOIL it out, there would be two terms that look the same. Plus b over 2a squared plus c minus b squared over 4a. And let's keep on walking. Let's distribute this a over ax squared. Before we distribute, maybe we'll notice multiply by 2, divide by 2, those two cancel. Plus a times x b over a plus a times, and let's square this out. So that'll be b squared over denominator 4a squared. And then the last term is plus c minus b squared over 4a. So some things will make you happy. There's an ax squared right there, which is good. I wanted an ax squared. A's cancel in that term. Oh, cool. That's the same as bx. I wanted to see a bx. That's nice. This a will cancel with one of those a's. B squared over 4a minus b squared over 4a. Oh, excellent. Those just cancel. And you're left with a plus c. Great. I wanted to see a plus c. So that formula is true. And how do you check it? You check it by just FOILing it out. So, all that checking was supposed to happen in here. Well. So let's use the same idea. Let's apply the completing the square formula to this. So that sure looks like our choice of A is 1/3. Our choice of B is -4. Our choice of C is 10. And if you'll allow me to pause for a moment. All right, wonderful. We're back. So let's apply the completing the square formula to this. So this will give me, let's give this a name so I don't have to write it again. Star equals A, which is 1/3, x plus -4 over 2 times 1/3 squared plus c minus b squared all over 4a. And in some sense, this is an answer, but it's obviously not simplified. This is equal to, the 1/3 I'll leave alone, x minus, of that minus, 4 divided by 2 will just be 2. So this can cancel down to a 2. I see division by 3. That'll become multiplication by 3. X minus 6 squared plus 10 minus 4 times 4 over 4 times 1 over 3. Why have I written it as 4 times 4 instead of 16? Well, because there's a 4 in the denominator that'll cancel with it. Now I can move this 1 over 3 to the numerator. Equals 1/3 x minus 6 squared plus 10 minus 12, 10 minus 12, also known as 1/3 x minus 6 minus 2. So what does that tell me about this? That tells me about the shape of the graph. This will be given by a quadratic function, upward opening. It'll get squished flat off, become 1/3 x squared. Oops, lost the squared. Then it will go right 6 and down 2. So the 20 around point, the vortex will be down here. It sure looks like, according to this, the y-intercept should be up here at 10. There'll be some x-intercepts, but we aren't really asked for them. There's the graph. Groovy. So with that, I'll go ahead and stop. I know this has been well more than an hour. What we'll do in class is you'll be able to ask me absolutely anything you want about any of these examples, about any homework examples. Wonderful. So I'll see you in class. I look forward to it. Ciao.